Hello everyone, welcome back to Calculus 1. This time we are moving to section 3.9. It's about the derivatives of exponential functions and logarithmic functions. I think the first result, as we already have mentioned several times, okay, in all mathematics, there's such a function such that the derivative of the function is itself. So it is about the exponential function derivative e to the x, it is itself. Well, I suppose we know this result for a while. And then the thing is, not only we needed to know what kind of new rules, and also remember the chain rule, product rule, quotient rule. And clearly, I think chain rule, it is maybe the most challenging one here. Okay. So combined with the chain rule, we have more generalized rule for an exponential function, derivative of e to the power of function. You always get the same exponential term back and then times the derivative from the exponent, that is the exponential function combined with the chain rule, And also, mostly in class, exponential functions usually we mean the exponential function, which means the exponential function with base e, but practically many times we do have the exponential function with base other than e. So if that is the case, how do we handle the derivative of an exponential function with base other than e? And so to handle an exponential function, not the exponential function, what you can do here is consider it logarithm. And believe it or not, it is very common. When you have trouble to deal with exponentials, you consider logarithms, and vice versa. If you have trouble to deal with logarithm, you may want to consider exponentials. So believe it or not, using logarithm, we can handle the base b somewhat in a fancy way, e to the log n of b. Like 2, it is e to the power of log n of 2. In general, we don't do such a conversion because clearly it's making it more complicated. But in calculus, somewhat, the conversion, this fancy conversion does help. So using the conversion for b to e to the log n of b, we can consider an exponential function with base b to an exponential function with base e. And then from here, I'm trying to highlight here, it is e to the power of a function, right? So using the exponential function combined with the chain rule, the general derivative, general exponential rule. Okay, we calculate derivative. We calculate derivative by keeping this original exponential function, take the derivative from the exponent, and maybe it's worth to focus on this log of n of b for a little bit. Many times we don't like to deal with logarithms, but anyway, in calculus, I suppose you know logarithm very well. And indeed, what I'm seeing here, the part I highlighted here, log n of b, it's nothing. It's just a constant. So the exponent, it is just a constant times x. So accordingly, the derivative of the exponent, it is just a constant, right? So it is the constant times the same exponential function, same exponential term here. Okay. And then this constant log n b stays, and indeed, this part of the exponential term still look very fancy, but anyway, see it clearly. I'm seeing this exponential term, it is converted from a very simple thing, b to the x, so it is just b to the x. So in other words, I'm saying derivative of b to the x, it is b to the x times log n of b. Again, I hope you do see log n of b. It is nothing unusual. It's just a constant. It's just a constant. So for example, if you consider derivative of log 2 to the power of x, that would be log n of 2 times 2 to the x. Derivative of 3 to the x, that would be log n of 3 times 3 to the x. Okay. And not only needed to know those calculus rules, that's what I meant, derivative rules, chain rule, product rule, quotient rule. You also need to know algebra very well. And this part, indeed, consider a single number into the combination of exponential and the logarithm. It's a little unusual, but anyway, it does help. It helps a lot about derivative over here, okay? And also, as I mentioned, you do need to know the derivative rules, all the derivative rules very well. So this part, it does involve the calculation of exponential function and the quotient rule. And it is from the textbook 3.75. So as I just said, I'm seeing this is the quotient, u as e to the x squared, v as x. So this is the quotient rule, u prime v, u v prime v squared. We need to calculate u prime. U prime, it is the chain rule, e to the x squared. The same exponential term back, and the derivative of the exponent, which is just 2x. Okay. V equals x, clearly v prime is 1. So I make the arrangement using the quotient rule. Y prime is such. Replace each notation with the formula. And then e to the x, it's a common factor. And also you look at the numerator part. There's x squared. X is also common factor. So also factor out x. Indeed, when you consider x as common factor, you can cancel 1x from the denominator. So in the end, I believe the answer should be correct. It is a simplified version, 2 minus x times e to the x over x. Exponential rule, derivative of the exponential function, and combined with the chain rule. I think I have another example. It is from the textbook. Checkpoint 3.50. Find the derivative of this. And well, I'm still seeing there is a chain rule involved. But anyway, the function h here, it is a product. So there must be u and v, right? I'm taking u as the x, v as the exponential function, e to the power of 2x. U prime is 1. V prime, it's from the chain rule. Make sure you do see this extra 2 clearly, okay? You know where this extra 2 comes from. Comes from the chain rule, okay? V prime comes from chain rule. Overall, the derivative of h, it is from the product rule. I have the product rule formula copy and paste here. U prime v, u v prime. So putting everything together, that is the derivative according to the product rule and the chain rule. And I think I have one more problem, and if you need it, you want to take a look at this problem. Indeed, I believe this is one of the homework problem. It's in the exercise part, number 335. The reason I'm choosing this problem because it's very interesting, as you can tell. And it has a lot of exponentials, e to the x, e to the negative x, and then there's a quotient. And certainly there are derivatives and there are chain rule involved. There's chain rule involved. So this is what I did. And first of all, because of the chain rule, well, derivative e to the x, it is e to the x itself, no doubt. But the derivative e to the negative x, I want you to know clearly, it is negative e to the negative x. Okay. And then the function indeed overall should be considered as a quotient. So I have u and v. Then I calculate u prime. U prime. Maybe I guess it would be better put them into a single line here. So u prime, it is e to the x, derivative of e to the x itself, then minus. But negative e to the negative x, it is giving negative e to the negative x here. So indeed, this is really e to the x plus e to the negative x. Then v prime, same issue about the derivative e to the negative x, it is negative e to the negative x. Okay. And then to find out derivative, I have the quotient rule. I use the quotient rule. I have u prime v and u v prime. And as you can tell, u prime v actually turns out to be the sign. So that's a perfect square. And the u v prime still turns out to be the same. That's another perfect square. the original denominator squared. The original denominator squared. Okay. And then what I did is I continued to multiply the terms from the numerator out. And the one thing you may want to be clear, e to the x times e to the x, it is e to the x to the power 2. It's not e to the x squared. It is e to the 2x. I hope you are convinced. Because really it is e to the x times e to the x. It should be e to the 2x. And similarly, e to the negative x squared, it's not e to the 2x or not e to the x squared. It is e to the negative 2x because it is e to the negative x times e to the negative x, which is e to the negative 2x. Also, the other thing you want to know here is e to the x times e to the negative x, it is 1. So in the end, this is the answer I got. And probably if you want to, you can do a little more work for the denominator part. But anyway, I think keep it like that should be fine. Keep it like this. What I leave here should be fine. Okay. So this part, it is the discussion of derivatives involving with the exponential function. Thank you for watching.